measures of position. And what about these measures of position? So the measures of position are actually used to divide a set of data or a distribution into equal parts in the attempt to describe the position of a certain data within that set of data. So the measures of position are the quartiles, deciles, and percentiles. Let us have the definition of the quartiles. The quartiles are the numerical values which divides a distribution into four equal parts. And to be exact, the number of numerical values pertaining to the quartiles is equal to 3. So there are 3 numerical values pertaining to these quartiles. And normally, we have these quartiles be named as the quartile 1 or the first quartile, usually denoted by Q1. And we also have the Q2 and the Q3. Having the first quartile, the lower quartile, and this one is the upper quartile. So anyway, I will be dealing with the details of this on my next slide, but for now, let us have the second quartile be the median. Because this second quartile actually divides the distribution into two equal halves, so as the second quartile will also be the median. And with that, we also have to consider other terminologies such as the interquartile range having a formula of the upper quartile minus the lower quartile, or simply Q3 minus Q1. And for our quartile deviation, we have this particular formula. And as you can see, this is your interquartile range, Q3 minus Q1, all divided by 2. So we can simply have this quartile deviation be equal to the interquartile range divided by 2. And now, let us have more details pertaining to these quartiles. Suppose that we are given with an array or a dataset containing these observations of 2, 3, 3, 5, 6, 7, 9, and 10. Then how we can illustrate the idea of the quartiles. So the quartiles is said to be these 3 numerical values that divides the distribution into 4 equal parts. And with that, knowing that we have this number of observations, 1, 2, 3, 4, 5, 6, 7, 8, then so let us enclose all these observations in a box like this, locating exactly the middle portion of the distribution, and we know this to be our median. So with that, the index is supposed to be given by n plus 1 over 2. Since we have 8 observations there, we have 8 plus 1 over 2, which happens to be 9 over 2, which is 4.5. So that means your median is located halfway between the fourth and fifth observation because we have a decimal point. And counting for these, we have 1, 2, 3, 4. So this is the fourth observation, this is the fifth. So the median is located halfway between those two. So this is your median. And as you can see, the median cuts or divides the distribution into two equal halves with 4 observations each. And with that, we can then again divide the first half into 2 equal parts, naming the quarters. Okay? So we have, obviously, by having a certain value here pertaining to the first quartile, then it divides the first half into 2 equal parts having 2 observations each. We can do the same for the other half that divides this into 2 equal halves having 2 observations each. Then we will have another quarter. And this will be your third quartile or Q3. So as you can see, if this is the first value pertaining to the quartiles, this would be the second value pertaining to the quartiles, and this will be the third value pertaining to the quartiles. And these are said to be the three numerical values that divides the distribution into 4 equal parts. And like what I have said a while ago, this will clarify the idea of having the second quartile be equal to our median. And what about the exact values of this? Because it is said to be a numerical value. So that means there is a certain value pertaining to the first quartile here that represents the value that actually divides this into 2 equal halves like this. So we will have that in our example later on. So this is how we can illustrate the idea of the measures of position specifically for the quartiles. And you just have to visualize this same idea for the deciles and percentiles, but we will not be having such here for us to conserve time, of course. And with that, let us proceed with the definition of the deciles. The deciles are said to be the numerical values which divides a distribution into 10 equal parts. And to be exact, we have 9 numerical values that divides the distribution into 10 equal parts. So like what I have said, we will not be having the illustration of this. You just have to use the idea that we have done for the quartiles. And with that, let us proceed with the percentiles. So the percentiles are said to be, again, the numerical values that divides a distribution into, this time, 100 equal parts. And with that, let us take a look at these equivalent positions, having our quartiles here, and the deciles, and here we have the percentiles. So anyway, what is the main idea for this? So let us go back with the illustration of the quartiles. So if we take a look at this distribution to be 100%, because this is a whole that refers to 100%. And if we divide such 100% into 4 equal parts, therefore, each quarter represents the 25% of the distribution. So this is a 25% of the distribution. This is another 25% of the distribution. And the same goes for the remaining quarters. And with that, the first quarter means that we have the 25% of the distribution, while the second quartile actually has this number of observations, the first 25% of the distribution, and the other 25% of the distribution gives us the 50% of the distribution. And if we take a look at this equivalent position, since the first quartile covers the first 25% of the distribution, so it would be equal to the 25th percentile. Okay? And with that idea of the second quartile that covers the first 50% of the distribution, then it will obviously be our median. Okay? And looking for the equivalent decile of such second quartile, it would obviously be the fifth decile. So if the decile divides the distribution into 10 equal parts, therefore the exact half of 10 is 5. Okay? So 10 divided by 2 is 5. So therefore the fifth decile is the median. And same goes for the percentile. If the percentile divides the distribution into 100 equal parts, therefore the exact half would be 50. Okay? So all of this Q2, D5, P50 are said to be the median. And now the other equivalent positions are shown in the table, like D6, P60, D7, P70. But knowing our third quartile be the 75% of the distribution, therefore it is equivalent to P75. So you just have to familiarize yourself with the equivalent positions like this. And now let us proceed with the formula for the index of this measures of position. So this is the same with the idea on how we can get the value of the median, because the median also pertains to a certain position that is exactly located in the middle portion of the distribution. Okay, so how did we get for the value of the median? Of course, we have to calculate for the index, particularly the location of the median in the distribution. Then after knowing the location, we will have to look for such value that refers to our median. And the same goes for the process of knowing the values of these measures of position. We have to know first the index or the location of a certain position in the distribution, and afterward, we have to carefully look for the value. Okay? So this formula, again, does not gives us the value immediately. Instead, only the location of the value. And with that, there is a certain similarity with the formula of the index for all of these measures of position, such as the quartiles, deciles, and percentiles. They are only, of course, changing with respect to their denominators like this. So since the quartile divides the distribution into four equal parts, we will obviously have this 4 in our denominator. So deciles, of course, divides the distribution into 10 equal parts. Therefore, our denominator contains the value of 10. And for the percentiles, we have a 100. And notice that all of these formulas actually have a similar numerator, and of which we have the index, okay, of the quartile. So if we are looking for the first quartile, therefore, your k is equal to 1. And we have to substitute that with this value of k right here. And simply have this be multiplied with n plus 1. And same goes for the rest. And now let us have this example. So here we would like to find the value of the indicated position in the given data set or distribution. And here we have these values. So as you can see, we only have the raw scores and they are not being arranged yet. But obviously, I have already prepared an array for this value. So this only gives you an idea that sometimes your given is not yet arranged in a certain order. So you have to come up with an array first before doing anything. Okay, so since we are already ready with that, let us proceed with the number 1. So let us try to find the lower quartiles. As like what I've said, the quartile 1 pertains to the lower quartile. What is our n first? So the n is the number of observations. So the total would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a total of 20. And now let us have the first quartile for number 1. So having a formula for its index. So we have k times the quantity n plus 1. And since we are looking for the first quartile, so your k would be equal to 1. So n plus 1 means that we have 20 plus 1 all over 4 because we are looking for a quartile. And with that, we have this be 21. So 21 times 1 is 21. And divided by 4, then that gives us 5.25. So that means the location of the first quartile in the array is somewhere between the fifth and the sixth number. So counting for 1, 2, 3, 4, 5. So this is the number in the fifth position, while this is the number for the sixth position. And with that, your quartile 1 is located somewhere between those two observations. So what about the value of that? So since your module gives you only one way on how to deal with the value of the first quartile, therefore, we will go by the module and use that same idea. So, but remember, this is not the exact value, rather a rough estimate of the value. Because knowing for the exact value, then we have to come up with the interpolation method. Since your module only gives us this idea, therefore, we will do the same. And that is by looking at the average. So the average of the fifth and sixth position, so that means the fifth number plus the sixth number divided by 2 gives us the value of the first quartile. So the fifth number is equal to 53, while the sixth number is equal to 55. So if we divide this by 2, then this will give us 108. So divided by 2, then it gives us 54. So the value of the first quartile is equal to 54. And now let us have the upper quartile or the Q3. So I guess we can still have this space be utilized for the computation of the number 2. So this is for number 1. And for number 2, so again, if we are looking for the upper quartile, that would be our Q3. So Q3, we only need to have this be equal to 3. The fraction, obviously, pertaining to that is 3/4. And with that, you have to multiply the numerator, 3, with the 20 plus 1. So this is obviously be equal to 21. And 21 times 3 gives us 63. And 63 divided by 4 actually gives us 1. And we have 23. So that means we have 15.75. Anyway, you may use a calculator for this. So that means it is somewhere between the 15th number and the 16th number. So again, if there are two numbers representing the value of the third quartile, then we may have to get the average of this. So your Q3 would now be equal to the 15th number. So this is the 10th number. So 11, 12, 13, 14, 15. So this is the 15th one. And this is the 16th. So anyway, let us check. 17, 18, 19, 20. Okay. So your Q3 is located somewhere between these two observations. And with that, let us look for the average. And the numbers are 78 and 81. So 78 plus 81 over 2. So it gives us 159. So divided by 2, then this will give us 79.5. And now let us proceed with the third example. And here we would like to find the fourth decile. So like what I have said, then we can have this be easily by having a fraction pertaining to the fourth decile, which is 4/10. And knowing that we have 20 observations, then we only have to do this 20 plus 1. And now we have this be equal to 21. And 21 times 4 gives us 84. And 84 divided by 10 gives us the index of 8.4. Okay, so that means it is located somewhere between the 8th number and the 9th number. And let us take a look at those. So this is the 10th. So this will obviously be the 9th number, and this will be the 8th number. Between this obviously lies the 4th decile, or the D4. So we have to look for the value. So obviously, knowing for the average of these numbers, we have 63 plus 64 divided by 2 for the value of the 4th decile. Then we will have this be equal to 127 over 2, which has a value of 63.5. So that would be for the 4th decile.